Thank you. Is this working? You all hear me? Maybe? Yes? Okay, great. Well, thanks for having this evening here with us. We're Spatial Pixel, and we're just really honored to be here with you this evening.
Yeah, and as former product managers, we know this is a really expensive meeting, too. So we're here to talk to you about spatial AI and spatial UX. And by the end of this talk, we hope to inspire you with a vision of how modern technology can make wonderful spaces. And before Spatial Pixel, I was director of AI at Consensus, which is a Web3 blockchain company. And I teach a course called Spatial AI that's all about spatial reasoning. And my background is in software engineering and product management, where I worked at companies like Pivotal Software and VMware.
And before I was at Spatial Pixel, I was director of product at Sidewalk Labs, which was Google's Future Cities initiative. And there I started this product that's a generative design product that's now part of Google Earth. That's the fun GIF you see in the upper right. But since then, I've been teaching concepts around spatial computing and physical computing at these different universities. So now, since working at those companies, we started Spatial Pixel. And that really combines these two topics from our different expertise. So spatial AI, about spatial reasoning, and spatial UX, which is really about interactions that take place in the physical world.
Oh, and on the right is Isamu. She's our closer. And we're building an open source spatial computer that is software-based. And so that's a lot of mentions of space. So believe it or not, as it turns out, we all live in space. But not outer space, but physical space. And so we're going to talk about ways to combine AI and UX to create new relationships with space. And why this emphasis on space? Well, we'll hold that thought, and we'll get to that a bit later. But as you know, the popular sense of tech today centers a lot around devices and code, but you still can't get away from space. In particular, in the US and many other countries, we learned during the COVID pandemic lockdowns that space really matters. Work lives of many were disrupted. The learning lives of children were disrupted. And for us, during that time, on a typical day, I could stand up from my desk, and all of a sudden, I was in a meeting at Google. I didn't really feel like I should be there.
He would literally peer over, and I would be on my computer over here. Because this is New York, so it's like tiny studio, right? So I would be talking to my colleagues, and then he hadn't signed any NDAs, but he was in every meeting.
Yeah, effectively. And there are always many emerging technologies, but we start asking the question, how could they be used to improve someone's experience in the physical world? So over the next half hour or so, we're going to share some of our tactics and experiments that we've been exploring at Spatial Pixel. Again, hopefully to inspire you to consider helping to build out these technologies so that we can create a healthier experience in the physical world. So we'll start with UX and natural interactions.
Great. So when we started working with computers, not us, but human beings working with computers, we started with the command line interface, where we had to speak very directly to the computer in its language through commands. And then we had this great invention, the graphical user interface, where we didn't have to speak with such explicit instructions. Instead, we had these representations that allowed us to communicate in the language of the computer, but without us having to have that exact same expression that the computer has. But what's interesting about this graphical user interface, if you take a look at that, this is probably from like the 90s. I'm actually not... does anyone know 80s, 90s? If you take a look at it, it's not too different from the interactions you have today. A lot of the paradigm we're still in is working with GUIs. But now we have this natural user interface that's starting to emerge, which really uses these other types of interactions that feel more, I'll just call them natural for now. So the difference between a graphical user interface and a natural one is that in the graphical user interface, we're using metaphor. So what do I mean by that? Let's say, for example, you have this chore app. And in this chore app, you have these representations in the interface that represent the real world. So in this chore, I have the kitchen. I have sweeping I need to do in the kitchen. This little box represents the kitchen. It is not the actual kitchen. When I do a chore, I might check a box that says, I swept the kitchen. That check mark represents the chore. It is not the actual chore. By contrast, a natural user interface tries to be much more direct. What I mean by that is the room becomes the interface. The fact that I swept this part of the floor is part of the interface. The way I'm moving my arm and the actual broom become the chore. And so we've had these tools to interact with computers from way before all of us were born, the keyboard, the mouse, and now we're starting to see a lot more natural inputs beyond the keyboard and the mouse. And what that means is that we have ways to leverage the way we communicate more naturally with each other and with the physical world. And that's one of these ideas we're particularly interested in exploring in our own practice, and hopefully something that you can explore as well. And so the next concept we'll talk about that we're starting to play with is multimodal AI. So this is a rising trend. You may have seen some of these products. And what we mean by multimodal here. Okay, so each one of these is using multiple modes. We have Humane using speech and location to call an Uber. This company archetype tracks whether your package has been shook, and that's just from various touch sensors and vision. Or if you're familiar with these new Orion glasses, you can see a range of food items and ask for a recipe. So before we had AI or multimodal AI, we had to give very explicit instructions to the computer. We had to give commands. So if I said, let's say I want to make a poster. I want to make a purple poster in my computer. I have to, step by step in sequence, say, put a rectangle here at this XY. I probably need to find each sequence of steps in the menus. And this is the paradigm we've been in until we started to have these intent-based interactions that are emerging now. So now, rather than focusing on that sequence of steps and giving very explicit commands, I can focus on the end intent I have. Give me an epic purple poster. Let's see what it looks like.
Yeah, and this is potentially a profound shift in the mindset of a user. Like while from a kind of HTML perspective, for example, it might just be a text box to a developer, but from the user's perspective, now they can declare the outcome that they want from a computer as opposed to the steps to get there. And so we move from commands and data entry to intent-based expression.
But what does intention look like if it's not just text prompts? So I have to apologize because there's a ton of images and video of me in this presentation, and I can't say that I'm not a narcissist, But the easiest way to communicate a lot of these ideas is just to video them. So please bear with me. Okay, so we understand intent by a lot more than text. Humans understand intent from our emotion, from what we say, from the tone of voice we take. Do I sound upset? Am I annoyed? What we point at changes what I'm talking about, what I mean by referring to things. Even drawing something shows kind of spatial relationships and associations. So that changes the meaning of what I'm saying. If I say this is up here and this is down here. Where I'm at, if I'm inside or outside, in Sweden, it changes the context of what I mean. Who I'm with, if I'm with my boss versus with my friends, don't say that. Or even just asking someone what they mean, right? We have these ways, if I say something and you're not really clear, you say like, hey, what did you mean by that? So we use all these different modes of communication to understand someone's intent. So if I say, I have a sketch in my hand and I say, hey, let's brainstorm this. You know that when I say this, I'm talking about the sketch in my hand. You know that when I say, hey, let's brainstorm this, you're all excluded. But if I say like, hey, let's brainstorm this, now like you're all part, he's left out. But if I say like, hey, let's brainstorm this, right? The tone. So what's really changing right now is that multimodal allows us to combine these different modes to communicate. So we've had all these, it's kind of amazing, we already have all these ways of understanding intent: mood detection, speech recognition, emotion recognition, gesture recognition, shape and object detection. You can even track someone's location. You can find out if a friend's nearby. If you don't know what ChatGPT means, you might just ask it. So what's really phenomenal right now is that multimodal can help us traverse those different ways of communicating, where in the past you might have to write very deterministic, predefined logic. And so here are some experiments, just little atoms of ideas around interacting in a more natural way with a computer that we're building up to be able to have a much more like overall natural interaction with a computer.
And each one of these that you're seeing here tries to use a natural physical interaction to program and manipulate virtual objects. For example, you can just say to the system, make this squishy, and it makes it squishy. Or you can grab something, like grab a virtual object with your hand and move it around. Or in the lower right here, under mimic, you could potentially express the complex behavior of, say, like a sprite in a video game just with your hand, rather than going through a process of tweening and keyframing.
Yeah, so I can say something like, hey, just make this move like this. Just think how much work it is to like say all of that behavior sometimes.
I guess it's the lower right for mimic. Mm-hmm. Speaking of space.
Great. So those are some of those atoms of interaction, but what happens when we bring that to a bigger scale? Like, what if I just want to say, like, hey, put this over on the wall or to the right of the door, to the right of the chair, the left of the chair? A blue circle moves between the left of the canvas and the left of the chair. A yellow circle and a green square fall on the chair. So this was like just some of the circles emerge, growing bigger from the center of the chair. This was just some of the very first experiments we were doing to see, like, hey, what happens when you add some of this logic in physical space? A grid of red triangles to the left of the chair. Quotes from the movie The Matrix appear on the left side of the canvas. You know you need this in your house. Random letters appear to the right of the chair. A large text clock appears on the chair. Okay.
Yeah, and so I think that particular experiment at the time was really surprising to us. Just for the hooking up a vision model to OpenAI's API, just asking it questions, resulted in all of that spatial understanding. So why are you all obsessed with space, you might ask? Well, before we were in technology and interaction design and playing with AI, we worked in architecture, but not software architecture, actually building architecture. And it turns out that architecture and computation have quite a long history. And so if you'll indulge me a minute with just a brief history lesson that you might not know about, you might know this work, Design Patterns from 1994-ish. Anyone? Anyone? Maybe? Okay.
All right.
At least we're on one same page. And you know this work. It discusses familiar name design patterns of object-oriented design, visitor patterns, factory patterns, singletons, and so forth. And the authors give a lot of credit to the architect and planner Christopher Alexander for inspiring their work. In particular, this book, A Pattern Language from 1977, which identified and cataloged emergent patterns of spatial organization in buildings and neighborhoods and cities. And so the idea that we have these object-oriented patterns comes in part from thinking in architecture. Similarly, William Mitchell, who was a professor at Harvard and MIT, in his book, The Logic of Architecture, proposed a systematic way of expressing the rules of design thinking through the use of natural and formal language. And so these rules were effectively like transformations. They described relationships, additions, and subtractions of different forms from one to another. And he uses this book to demonstrate and show what is effectively a large search space of possible building designs, in this case, Renaissance villas. And so this starts to hint at the idea that space can be described with programming languages. Also similarly, Cedric Price was a British architect who in 1964 partnered with the theater producer Joan Littlewood on a project they called Fun Palace. And it was an idea for a building that could adapt to the programs and needs of its occupants in a way that could adapt quickly over time. And in the documentation of the project, we found some remarkable diagrams like this from Gordon Pask, who's a psychologist and cyberneticist, among other things, remarkably similar to the diagrams that you might draw today in UML or some other language. So projects like the Fun Palace, particularly from Cedric Price, embodied this idea of what we call programmable space. And so these buildings and projects they were intended to be interactive and changing, almost like software itself. And you can imagine big gantry cranes and mechatronics and sensors that would move pieces of the building around as users would express their needs and intent, and it would respond to their presence and preferences. And so, but while Fun Palace wasn't realizable at the time, you can imagine complexity and budget might have gotten in the way. Technologies like multimodal AI and LLMs make this possible today. But how do we make this idea of programmable space accessible to the occupants of those spaces who aren't engineers? and for designers as well, and architects, dancers, actors, anyone who is sort of interested in the qualities of space around them. And so one thing that we're exploring is what we call natural language programming. So the ability to express coding logic with natural language without worrying necessarily about the code and syntax itself. And there's some precedent for this. There's some precedent for a kind of simplification of complex code. Processing out of the MIT Media Lab, for example, has spawned an entire community of creative coders in the time that it's been around. And its intent was to empower a certain class of creative to rapidly explore graphical and interactive ideas in code, but without necessarily having the discipline of a software engineer. And so similarly, we're exploring with ways of enabling communities of creatives to explore how to program with natural language in a similar way. And Funkify is one such way. So this is just a web app that's similar to OpenAI's Playground, but made specifically for experimenting with the function calling feature of large language models. And so our students use this to explore how to bridge the gap between intent-based text prompts and data about the physical world. And so you can see here a query that uses the Mapbox API and a function that is the bridge between those two. And there are other queries as well that are spatial in nature. And so, but unlike the Playground, actually this allows you to implement the functions like right there in the browser. And what we discover in this process of exposing these kinds of techniques to creatives is that counterintuitively, what's great about natural language programming is the non-deterministic nature of the LLMs that power it. And so it's particularly useful for creatives who like to iterate and like to see variety and like to see surprises in the work that they do. And so these LLMs really start to show us the possibilities of a given logic that they are programming with these text prompts.
It's kind of interesting, just having started to play with some of these natural interactions and natural language programming with students, because that whole point about non-determinism becomes really important. Like if you've ever tried to develop, any indie game developers here, or like people using Unity or playing with building games? Yes, I see you. Well, when you're developing something like a game, you really don't know how it's going to behave until you make it. You're like, it might be fun, but you don't know until you try it. And so it's really nice to have students building these functional prototypes, but also being able to create those interactions. But natural language programming isn't going to get us to the amazing, responsive Cedric Price building. We still need a way to tie it back to space. So with programmable space, we have to first find a way to understand what's going on in that space. So this is one of our environments that we've built up. And what's really important here is that we're trying to sense and understand what's going on. We've probably, you've probably all seen car counting capabilities. That's not really the novelty here. The novelty is that ability to express that logic and behavior with plain language. So for someone that's not an engineer or without this background, this becomes really important for being able to express fully operating programs. All right.
That's my hand.
But it's not just expressing behavior to something like a computer or a phone. We can actually program devices, door locks, sensors, cameras, projectors, and understand their spatial relationships. And that's where it starts to get a little bit more interesting for programmable space. So here we have William programming an RFID reader. as he's making some tea. And this isn't just about home automation. The really important idea here is that someone's going to be able to program natural interactions in things like gesture in all kinds of spaces. So like in a theater or a workspace, or can you imagine being able to control some of the capabilities in this room?
It's the best acting job I've done yet. Yeah. It's also my bad coding. So another tactic that we think about with spatial computing is how can we make some of this like truly spatial, like in physical space. And so, as you know, like for about 100 years or so, screens have been drifting sort of closer and closer to our faces. First, starting with theater and the moving picture, where it's kind of this distance away, and then televisions at home, where a kind of family unit can sit much closer to the screen. Personal computers, where it's about a meter or less in front of you, and then mobile devices, of course, where you have the option of where it goes. And now, like right up, screens right up in your face. And at the same time, like we've become a more global society, and yet somehow more disconnected from each other. And we know now that a lot of these individualistic technologies can make our experience more isolating, and can even make us like more susceptible to manipulation by advertisers or disinformation. But AR and VR glasses are obviously a big deal now. There are a lot of companies still investing in them, and some of them are really cool. It might make friendship a little awkward if you're the only one without them, but nevertheless, Apple Vision Pro has repopularized the term spatial computing. There's a lot of advertising around VR for architects, which doesn't quite reflect how architects work, but it's still kind of a fun idea. And I couldn't resist referencing the screenslaver from The Incredibles 2, which really highlights the risks of letting a self-proclaimed tech genius like put VR glasses on your face. So if you haven't seen this movie, it's great for parents. So, is it playing? Oh, yes. So what Violet has shown before, Procession is the software-based spatial computer that we like to say is for your space and not for your face. So hopefully it becomes a complement and a kind of place of contribution for people interested in these ideas. But we can extend some of that logic that is now in mixed reality and virtual reality and augmented reality, but instead leveraging projection, sensors, and all the like, and finding a kind of way for all of those data and interactions to mix together. And so hopefully some of you would be interested in contributing to the open source project of this when we release it, hopefully to contribute your knowledge and talent to connect all of these multimodal AI in this fluid way. So you can share your superpowers with the creatives and spatial designers who really need it. So.
Great. So I think, we've shown all these different interaction patterns like natural interactions, natural language programming, using multimodal AI, programmable space. But I think one of the most important things about all of those emerging capabilities and this idea that rather than programming in the computer, we can program the space itself, is that our interactions can become collective and not just individual. And when you start to sit back for a moment and just think about how much we've invested into the individual computer, it's everywhere. The iMac, eyeglasses, iPhone, even the user experience is about the individual. And it's not that we don't think that we should have individual computing, but we also need modes for collective computing so that we can get back to our interactions with each other and back into physical space where we all live. So this was a, oh, yeah, go ahead.
Oop.
Click it.
It played, but it didn't play.
So this was an experiment we did in a pop-up gallery in Philadelphia. And this gallery was inaccessible to the public. And so we did this just very simple thing of setting up a bunch of RFIDs and this cigar box that inside the cigar box had the name of the artist. And so as you move this cigar box around down the RFIDs, it was connected to a projector that selected the artist's work in the space. And so, here we're not using any AI. It's a very simple setup. But what was really interesting was that people started to interact a lot more with each other rather than with the device itself. They started teaching each other how to use it. And they were just very inspired by very simple interactions that can get people to interact a bit more with each other in the moment than with a screen. Great. So we think we also, along with this, that we can have this return back to place. Another tactic is to consider place over the interface. So this is my self-portrait. That's me. When we work on computers, we so often find ourselves having to go into the computer, having to speak the computer language. I actually had to crop this, your password must. It was much longer, all the rules. My password is coconut12, exclamation, 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 3 for security. But, we have to, even when you do any kind of interaction on the computer, just think about how disjointed that can feel sometimes. Even booking a flight, for anyone that came here, you're checking your calendar, and then you're checking your email to see, okay, when was the day? And then you're looking at a map to see where is that actual location of that airport. And this is all after these login flows. So you're really entering that kind of sequence that, if you were talking to a person, maybe wouldn't be as fragmented. So we continually find ourselves jumping into the interface or into the computer. And we like this idea of what if our interactions could meet us where we're at, in the kind of mindset we're in, the context, what activity are we doing in that moment? How do we get interactions to come into our world versus us going into the world of the interface?
And so for example, we've started experimenting with information systems that sort of, again, meet you where you are. And so I don't advocate using alcohol for stress relief, but let's say you log off Zoom and someone recommended a cocktail to you and you wanted to try that out. And today, a typical workflow is to grab your device, authenticate, open a browser, search, then you manually search through the search results, which is a bit of an irony. And then once you find the result, you sort of scroll through someone's life story before you get down to the ingredients for that cocktail. And by that time, you really need that drink. As we know today, large language models allow us to access this information in the way that we want. You can just ask Claude or ChatGPT and say, give me the ingredients for this, and it will do it. And we started asking, what if we could take that a step further, have a system that knows where you are, and then has ways of displaying that information in a way that keeps our attention more passive rather than active on the device. And so you can imagine getting those ingredients while you're entertaining guests, while your hands are sticky with sweet vermouth, and so on and so forth.
Yeah, so we like this kind of movement from things like dumb phones and these low stimulation, low sensory interactions. This idea that computing in some moments can be more peripheral, can be mentally quieter.
And so we make this distinction between location and place. So we all know that location data is a thing. And so location in space, like on our mobile devices, is described with, say, GPS coordinates. But place is this notion of a location that also includes the rich context that it has, personal memories, the history of the city, sort of neighborhood lore, like what bar was here before and who met there. And so the new AI models allow us to, when we express our location, help us leverage that rich context at the same time. And so much information is embedded in our physical environment. Like oftentimes that information as well never makes it into a digital system and never will. So street parking signs, for example, at least in major cities in the US, there often isn't a centralized database that has, on a particular street, on 3rd Street, like here's the parking situation and where are you allowed to park and so on and so forth. The city itself becomes the documentation. And so if that never makes it into a digital system, how can you use it and interpret it in a way that makes that more accessible in a similar way that a large language model makes like cocktail recipes more accessible? And so what if you could walk around a city, point to a sign, and just ask about it? And so in this demo we call Talk to the City, we were still experimenting with how to combine like these multiple sources of data and combining them into a vision powered LLM. And so these queries that you're about to see are filmed live. Violet sort of has like a rig that just below the camera line.
What was important to Philadelphia about Quakers?
Quakers were integral to Philadelphia's founding, emphasizing religious tolerance and participatory government.
Does the 5 go to Liberty Lands Park?
The SEPTA Route 5 bus does not go directly to Liberty Lands Park.
Where does Route 48 go?
The SEPTA Route 48 bus travels from the area of 27th and Allegheny to the Frankfurt Transportation Center.
Can I park here right now?
Yes, you can park there, as the sign indicates the restrictions apply Monday to Saturday, and it's currently Sunday.
What's the most popular place on this list?
The most popular place listed is likely the Independence Park sites, which includes historic attractions like Independence Hall and the Liberty Bell.
What is currently playing at the Arden Theater?
The Arden Theater Company is currently showcasing Lady Sitting, which has been extended and runs through March 3rd.
Great. So our students have been playing with a lot of the tools that we've been developing. And so what you're seeing here is this medley of students from these different classes. And what's interesting as well is they tend to come up with ideas that we definitely would never think of. In the top, you're seeing students developing a digital and physical Rube Goldberg machine. So like getting things to trigger and collide both in physical space, but then if like a sound happens, then that triggers something on one computer. And if that computer does something, that'll flash a light that then triggers another thing. And it's really interesting just to see these students from different kind of backgrounds, what they start to do when they're interacting in this programming in plain language, but also programming things that occur in physical space.
I really like the woman that was watching a movie, and when she got up to go to the bathroom, the movie paused automatically and then restarted when she came back. Stuff like that.
Yeah. So like a lot of the physical computing students are working a lot with sensors and actuators. So, turning lights on. There's one student that has a project where you're like pointing at different things or looking at different things in the room to turn them on and off, which I think has a lot of potential for things like more accessible interfaces. And then we have students in engineering school at UPenn that's LLMs for UX prototyping class, and they approach it from a very different perspective. It's like, what kind of new interaction capabilities exist now that we can use things like natural language programming directly in an interface? So I think it has a lot of implications for all these different disciplines, like the students from architecture, the students from engineering, the students from physical computing. They're each kind of uncovering different dimensions just by experimenting and playing with the tools.
And so when we talk about creatives, like normally we think about artists and designers and architects and so forth, but engineers are a creative force as well. I mean, we all know back in the 1970s, companies like Atari created a new medium called video games that combined moving images, sound, storytelling, all made interactive. And we think that we're now at a similar moment where we can create this new medium to make space digitally interactive and accessible through natural interfaces and natural interactions. And so again, we hope this inspires you to create in this new medium and think about how your interactions can take place outside of the computer and in a shared physical space that we all occupy. So.
Great. So we'll leave you with these tactics. We hope that we see you in space and developing these interactions in physical space.
Thank you.
So thank you very much. Thanks for having us today. Yeah.